Hi, this is Janardhan. I'm going to explain you how I implemented global sequence alignment in a computer program using C language. This is my motivation. Some of my teachers and friends were curious of how I implemented the global alignment of sequences based on Needleman-Wunsch algorithm in a C program. I felt it important to explain them the elegance and simplicity of the complex underlying computer program. So this is the objective of computer program. We have two sequences of different lengths. After global sequence alignment, we should be able to generate alignment of these two sequences. So let us quickly look about the theory behind sequence alignment. So the purpose of sequence alignment to identify the regions of similarity. Gaps are inserted between the residues so that identical or similar characters are aligned in successive columns. Aligned sequences are arranged in a matrix. For example, I found an alignment of histone proteins of various mammals in Wikipedia. The alignment looks like this. Histone is a general protein in various mammals used for DNA packaging. So this is why we do sequence alignment. There are many sequences with unknown structure, and there are only few sequences with known structure and function. If we align them and find similarity, we might find the structure and function of unknown sequences, and we can also identify conserved patterns called motifs. Similar motif content might hint to similar function. So global alignment we do from beginning to the end of the sequences is based on Needleman-Wunsch algorithm. Local alignment we do for very dissimilar sequences where the boundaries are not known properly. It is based on Smith and Waterman algorithm. We use the same dynamic programming in two cases, but the choices from where to start and where to end differs in global and local sequence alignments. Global alignment we do for sequences in which boundaries are well defined. These are the three steps in dynamic programming. Initialization, we set up a matrix. Next, we fill the matrix with scores and directions. In the following computer program, I generated two separate matrices for scores and directions. Those are score matrix and traceback matrix. And next, we align the sequences using the traceback matrix. So this is how a matrix looks like. We have, suppose we work on a present cell ij in the matrix. We have the diagonally opposite cell I minus 1 j minus 1, the top cell I minus 1 j, and the left cell I j minus 1. This is what happens in dynamic programming. Optimal path is detected by incrementally extending the optimal subpaths. The overall goal is to find the path moving along the matrix with maximal score. The path specifies the optimal alignment. Optimization is achieved by giving a high score, positive for a match, low score or negative for a mismatch, and penalizing a gap with negative score. So let us take an example. The letters of the sequences, the pair of sequences are arranged in a matrix. Columns represents the letters of the first sequence and the rows represent the letters of the second sequence. One sequence is arranged in a horizontal way, the other sequence is arranged in a vertical way, and after representing the sequences in rows and columns and each cell of the matrix, the individual letters are compared. So we take two sequences B, C, D, E, so on up to O, and second sequence capital B, capital C, capital D, so on up to O. Capital A and small a are spaces, null characters concatenated to the strings, intentionally added to the strings. The corresponding score is always 0. That is the initialization of the matrix. So after initialization, the matrix looks somewhat like this. The first cell, the top left cell score is 0, and at the each cell the alignment score is as shown in the scheme below. It can be one of the three scores: score from the diagonal, it is the score of the diagonal cell plus match or mismatch score. It can be the score from the left cell, that is the score of the left cell minus gap penalty, or the score from the top cell, that is the score of the top cell minus gap penalty. This is the scheme for giving a score to a cell in a score matrix. Yes, AI, BJ might be a match or a mismatch score. In the example, if capital E is equal to small e, we add a match score. If capital E is not equal to small e, we add a mismatch score. Mismatch score is usually negative. So how I implemented in the C program? So scoring matrix, so simple. So I took two loops, one loop inside the other, nested loop. You can see I have two conditions. If the two letters are equal, gene 1 I minus 1 is equal to gene 2 j minus 1, then it's a match. Then I add the match score plus the diagonal score to give the score of the present scale. Else, if the two letters are not the same, I add mismatch score to the score of the diagonal cell, and there are two more scores: score x, that is the score from the left cell, and the score y, that is the score from the top cell. So we have three scores. The score of the present cell will be one of the three scores. We take the greatest of the three scores, and here is the flowchart. Finally, after applying greatest function, we obtain the score of the present cell. So here is the greatest function, which takes the greatest of the three scores. It's a three variable judging between the three variables which is the greatest. So I divided the problem into two, taking two variables at a time, x and y. I took x and y. I divided into two conditions, x not equal to y and x equal to y, and inside x not equal to y I checked for other conditions. Similarly, in x equal to y I checked for other conditions. Finally, to judge which is the three, you can see when two variables are equal or two scores are equal, I gave importance prior to one of the scores, so that multiple scores in a cell won't arise. Greatest function judges the maximum of the three scores. This is a part of the flowchart of the greatest function. I have drawn only for one condition. So here is the important part of the program, the traceback matrix for storing directions, and how I implemented in the C program. I took three array variables for storing three directions: diagonal, left, and top. These are two-dimensional arrays. You can see if the score of the present cell ij is equal to the score of the diagonal, TBO will be set to a character x. Similarly, if the score is from the left, character TBX will be set to character caps, and if the score is from the top cell, character array variable TBY will be set to the symbol less than. By default, TBO, TBX and TBY are initialized with blank spaces. That is, initially they don't have any direction. The greatest function eliminates the possibilities of multiple directions by giving high priority to one of the three scores in case they are equal. Finally, only one of the three scores is stored in a cell of the score matrix. This helps in a unique direction in the traceback matrix. This makes the program more efficient. See, multiple directions in each cell are eliminated by greatest function. Only single direction. We have only single direction in each of the cells. Three directions are stored in three separate array variables, and initially they are by default blank. So based on what the greatest function returns, TBO, TBY and TBX are set to X to the power of and less than symbols respectively, and we don't have symbols for diagonal arrow mark, top arrow mark and left arrow mark, so I have used these symbols X to the power of and less than symbols. This is the flowchart for setting directions in the traceback matrix. This is a simplified flowchart. I didn't specified any loop in the flowchart. This this flowchart has to be iterated many times till all the cells are covered in the traceback matrix. So we take an numerical example in which I set the match score to +5, mismatch score to -3 and gap penalty to -4. And please mind that these scores need not be the same. You can give different scores. So I arrange the nucleotide sequences in rows and columns, and a matrix is set. Top corner, left corner cell score will be 0, and because the first row and first column are spaces, it doesn't match with any of the letters in the two sequences, so the gap penalty gets added up. We have negative multiples of 4 in the first row and first column. See, in the one by one cell we have three scores. Score from the diagonal, that is 0 plus 5, and score from the top cell, -4, that is -8. The score from the left cell, -4, that is -8. Out of the three scores, 5, -8 and -8, 5 is the maximum. So the score of 1 by 1 cell will be 5 and the direction is set to the diagonal. You can see the black arrow mark set to diagonal. Similarly, all the scores and directions are set in the each cell, in each of the cells. Finally, all the cells are filled with scores and directions. And I generated two separate matrices for scores and directions. For scores, it is the scoring matrix. I have only the numbers here, and in the traceback matrix I have only the directions. X represents the diagonal direction, less than symbol represents the left direction, left arrow mark, and up to the power of symbol represents up direction, up arrow mark. You can see in the scoring matrix the bottom right corner has the highest score. We start the traceback from that cell. Traceback is the alignment of sequences using the traceback and scoring matrices. In the traceback matrix, we look to see where we move next according to the pointers. So we start from the bottom right cell in which score is 11, highest, and it points to the diagonal where the score is 6. Similarly, we move to the next cell and so on till all the letters in the two sequences are covered. This is how I implemented global alignment using traceback in the C program. I initialized two variables x and y with the lengths of the sequences L1 and L2. This makes sure that the traceback begins from the bottom right. I initialized some three new variables: next door, next x, and next y, with direction array variables tbo, tbx, and tby, so that updating will be easy. The variable agil keeps increasing till all the letters in the two sequences are covered. You can see the condition gene 1 not equal to space g and or gene 2 not equal to space. This condition makes sure that all the cells in the traceback matrix are covered. AG1, AG2, and bar, these are the array variables for storing sequences after alignment. These are array variables, and bar is an additional array variable I used for putting bars where I have matches, and where a gap was not introduced in the sequences. So the first condition, if next O is equivalent to symbol X, that is the symbol used for diagonal, we don't introduce any gap in the sequences. We just print the characters as it is, and we put a bar between the characters. And in this case, both X and Y variables are decremented, so that the next cell is the diagonally top diagonal cell, top left diagonal cell. We have two other conditions. If we have to the power of, it's a mismatch, only Y is decremented, so that the next cell lies at the top of the present cell. In this case, I decrement only the y variable, so that the next cell will be the top one, top to the present cell. Similarly, if I have a mismatch with if I have a less than symbol in the traceback matrix, it's a mismatch. So I I decrease only the variable X, so that it points to the left cell. I introduce gap only in the second sequence. For the top case, I introduce gap only in the first sequence. This is the code I use for updating the directions in the traceback matrix. Every time the matrix index variables X and Y are updated, they point to the next cell of the traceback matrix based on the symbols X for diagonal, to the power of for top, and less than symbol for the left cell. The directions are updated according to the directions of the next cell. You can see in each case, for diagonal case, both X and Y are decremented. For top case, only Y is decremented. For left case, only X is decremented. And while updating the directions, you can see the array variables TBO, TBX and TBY has X and Y. Those are decremented according to each of the if conditions, and XO, next O, next X and next Y variables are updated accordingly according to the decrementation done in the if conditions. So this is the flowchart showing how I did traceback using how I did global alignment using traceback. You have three conditions, one for diagonal, one for top and one for left cell. For diagonal, no gaps are introduced. The pointer, both the variables are decremented, and the diagonal cell is pointed. In the for top case, gap is introduced in the horizontal cell. The vertical cell, the letter is printed. the pointer points to the top cell. For the less than case or the left case, gap is introduced in the vertical sequence. The letter in the horizontal sequence is printed, and the next cell will be the left cell, because only the x variable is decremented. Okay. This is only for one iteration in the nested loop for covering all the cells in the traceback matrix, and every time this is done, directions are updated after x and y are decremented based on the 3 if conditions. This is only for one iteration in the nested loop for covering all the cells in the traceback matrix. So this is the input. I give 5 plus 5 for plus 5 as math score, minus 3 as mixed math score, and minus 4 for gap. I give two sequences, GAA double T CAG double TA, and second sequence double GAT CGA. This is the input. Match, mismatch, and gap scores are 5, minus 3, and minus 4 respectively. And the two nucleotide sequences are GAA TT CAG TTA and GGAT CGA, and the final output will be this. You can see a scoring matrix showing all the scores in each of the cells, and the traceback matrix showing the directions in each of the cells, and the sequences are aligned with bars at which there is a match and where gaps are not introduced. So this is something about the final input. Please note that this alignment, global alignment of two sequences, may not be unique in all the cases, because there is a possibility of multiple directions in each cell of the traceback matrix. A cell may have more than one direction, but in the C program I have written, I made sure that there is only one direction so that the traceback will be efficient. I have introduced gaps in the sequences for optimization. I have generated one more string called bar for showing the user where the strings are printed without gaps. This is the final output. See how sequences are arranged beautifully. This is the global sequence alignment. This is the overall flowchart of global sequence alignment. I start with giving match, mismatch, and gap scores. I have given a pair of sequences. Then I computed the scoring matrix. Then I computed the traceback matrix from the scoring matrix. Then I aligned the sequences globally using the traceback matrix. That's it. not just nucleotide sequences or amino acid sequences. I can do alignment for any strings, any kind of strings. For example, I give two strings which are my nicknames, Johnny and Johnny. The score of the alignment will be the score at the bottom right corner cell of the scoring matrix, that is -3. We start the traceback from there, and you can see the beautiful global alignment of sequences, Johnny and Johnny. So my friends kept asking me from where I got this idea. This is my inspiration. This is from where I got the idea. Linked list. A linked list is a linear data structure in which an element points to the next. In sequence alignment during traceback, each cell points to the next based on directions. This vague similarity tempted me to try the algorithm in a C program. Uh, I used to do a lot of programming on data structures during my bachelor's. When I worked, I used to do program on linked list where I used pointers. The pointer is pointer points to the address of the next element in a linked list. So I was inspired by the programming I did during my bachelor's of engineering. This is from where I got the idea for doing program on global sequence alignment. You can download the program, C program, from the link provided below. You can also download the content of this video as a PDF. So these are my teachers who taught me bioinformatics and computer programming. Bioinformatics was taught by Professor J.S. Prakash of my department, and computer programming was taught by Dr. Pankaj Singh Dolania of my department. I thank my classmate Krishna Priya for teaching me global sequence alignment, and my hostel mate Jonathan Kotkapu for providing me his laptop for doing the programming. I thank founders of Wikipedia from where I borrowed the definitions and some diagrams. These are the compilers I used when I used Turbo C++ compiler. The entire program was compiled and run successfully. There were no errors during compilation and running of the program. Global sequence alignment was done successfully, but when I used GCC compiler, there was a segmentation error. The built-in string functions were not working, and the loop went infinite. The loop, the final loop for aligning the sequences was not working. You can help me why GCC compiler is not helping me in compiling and run the program. You can write a comment on why GCC is not helping me run the program. This is the operating system I used, Windows 10, developed by Microsoft. I did the presentation using Microsoft PowerPoint. Video recording I'm doing using Xbox game recorder. I also used Ubuntu operating system for GCC compiler, but GCC compiler was not so helpful for me. This is my contact. I belong to Department of Biotechnology and Bioinformatics, University of Hyderabad. I live in Visakhapatnam. These are my phone numbers. This is my email ID. You can contact me for any queries. I dedicate this work to my parents, brother, teachers and friends, especially some of my friends who kept asking me how I did the program. Thank you everybody. Meet you again with another video, like a video on how I did C program on local sequence alignment. Goodbye.